this lesson, we will look at some of the properties of the set of whole numbers under the addition operation. The first property we want to explore is called closure. A set is closed under an operation if we can take any two elements from the set and perform the operation and obtain a result that's also in the original set. For example, let's take the set of natural numbers and the operation of addition. We can scan through our set and take two elements, such as 2 and 3, and perform the operation of addition to get 5. 5 is an element of the set of whole numbers. Hopefully you can convince yourself that it doesn't matter which two elements we start with, we're always going to get a sum that's a whole number. So this set is called closed under addition. The next property is commutativity. We say an operation is commutative if we can switch the order of the objects we're working with and the overall result doesn't change. For example, if we take two whole numbers, 3 and 4, we can add them together and get the sum of 7. Notice that if we switch the order so that we have 4 plus 3, our overall sum is still going to be 7. In general, we have a plus b is equal to b plus a for any two whole numbers. In other words, the order of our addends doesn't matter. We always get the same sum. Let's take a look at a few real-life examples to get a better sense of what we mean by commutativity. First, let's look at putting on your right shoe and putting on your left shoe. Notice that it doesn't matter if we put the right shoe on first or the left shoe on first. The end result is that we're going to have both shoes on. So these two actions are called commutative. Next, let's look at washing your clothes and drying your clothes. Well, we could wash first and then dry afterwards and have clean, dry clothes. However, if we dry our clothes first and then wash them, we're going to have clean, wet clothes. So these actions are not commutative because if we change the order of them, the overall end result is going to be different. The next property is associativity. We say an operation is associative if we can perform the operations in any order and the result doesn't change. For example, let's take the three whole numbers 2, 3, and 4. We could add them together 2 plus 3 first to get 5 plus 4, and that sum is equal to 9. Or we could add together 3 and 4 first. That's going to give us 2 plus 7, which is also equal to 9. So either way, we still end up with a final sum of 9. In general, we might write that a plus b, and then adding to that c, is the same thing as a plus b plus c in brackets. So in essence, the order that we perform the addition doesn't matter. We're always going to get the same final sum. Let's take a look at a few more real-life examples. Let's consider putting on underwear, putting on pants, and putting on a shirt. Well, if we group it together like this, we could put on our underwear, and then put on our pants, and then finally put on our shirt. If we dress in this way, we're going to be properly dressed. However, notice that we probably wouldn't want to get together in this order by putting on our pants first, and then our shirt, and then putting on our underwear last. We might get some funny looks if we went outside if we chose to put our clothes on in this order. So we might say that these three actions are not associative. Next, let's take a look at paying your Netflix bill, paying your phone bill, and paying your rent. Notice if we pay the Netflix bill and the phone bill first, followed by paying the rent, that's going to be the same thing as paying the phone bill, paying the rent, and then paying your Netflix bill. All three bills are going to be paid. So these three actions are associative. Finally, the last property we want to explore is the idea of an identity element. For this particular property, we're going to need both a set and an operation. We're going to take the set of natural numbers, n, and the operation of addition. The set of natural numbers has an additive identity if we can find an element satisfying a plus e is equal to a. In other words, we start with our number a, we add e to it, and we get A as a final sum. And this relationship has to work for all elements of our set. Let's take a look at a numerical example. We might say something like 3 plus what is equal to 3. If we could figure out what goes inside of this question mark, that would be a candidate for the additive identity. Is there a number that I could put in for the question mark that makes sense? Sure, that number is 0. So we call 0 the additive identity of the set of natural numbers. Let's sum up our main ideas here. The set of whole numbers is closed under addition. We can add any two numbers together and get a whole number. Addition is both commutative and associative. This means the order of the addends doesn't matter, and the order that we perform our additions also doesn't matter. We're always going to get the same final sum, which is pretty awesome. Finally, the additive identity in the set of natural numbers is 0. This means if we add 0 to any number, we're always going to get our original number as the final sum. All right, my little epsilons, stay positive.